Okay, let's start chapter 19, Aldehydes and Ketones. It's a long one, so let's get started with a slide here that talks about what aldehydes and ketones are. So, both aldehydes and ketones possess a carbonyl group. So, I think by now most of my students know what a carbonyl group is. So, sometimes my students will refer to it as a C double bond O, but the proper name is a carbonyl, and we're putting the valence electrons there. Important in both biology and industry. Well, of course, if you've ever purchased nail polish remover, that's acetone, and you can buy it in the paint section at Home Depot. Sometimes it's used as a paint remover. And if you've ever done a biology lab before, you're probably had some experience with formaldehyde. So when formaldehyde is put in water, you get formalin, and that's used as a preservative. So there we go. Aldehydes and ketones are everywhere. What else? If you've ever had vanilla flavor, so that's vanillin, it's used in the lab here at UCCS. Also benzaldehyde, the one on the far right here, that's used in it's an almond flavor, so it's used in cakes and cookies or whatever. And then you have arcarvone, which is spearmint flavor, that's found in lifesavers and Wrigley's gum and all those kinds of things. And you've probably seen the structures of these two steroids here, progesterone and testosterone. And now you know they both end in -one, so they both have a carbonyl flanked by two carbons, so they're both ketones. Anyhow, so those are some common ketones and aldehydes. What else? How do you name an aldehyde or a ketone? Well, we're going to kind of do this in a couple steps, but there's 4 discrete steps to naming an aldehyde or ketone. Same procedure that you use with alkanes and alcohols and alkenes, etc. So if you've mastered the nomenclature from other chapters, the nomenclature from this chapter is not that bad. There's just a few nuances to learn. So, of course, you find the parent chain that contains the functional group. You identify and name the substituents. So, is it an isopropyl, a bromo, a fluoro, etc.? You assign a locant or a number to each substance. So, is it 2,2, difluoro? Is it, 2, 3, whatever? And then you just assemble the name alphabetically. So, and I would add at the end here, step number 5 would be to assign stereochemistry. So, if there are stereo centers, you're going to have to include RNS. So we'll just call it RNS, so stereochemistry. All right. So anyhow, here's some examples. It says identify and name the parent chain. So for aldehydes, you replace E at the end with al. So if you had butane, you'd have butanal. If you had pentane, pentanal, hexanal, heptanal, octanal, nonanal, so on and so forth. There's also common names that are used for aldehydes, and I'll get to those in a second. So the parent chain has to include the carbonyl carbon. So you can see that I think everybody knows how to name a molecule like octane by now, or this octane derivative rather. So this would be 4-methyl-octane. But with the aldehyde, you got to keep in mind that the parent chain has to include that carbonyl. So yes, there is a chain that's longer than 6 carbons, but it doesn't include the carbonyl from the aldehyde. So we would number like this: 1, 2, 3, 4, 5, and 6. And just as an aside, something nice about aldehydes is that you don't have to include a locant for the carbonyl in an aldehyde because it's always at the end of a molecule. All right, so let's see here, nomenclature. So the aldehydic carbon is always assigned number 1. So here's a couple of examples. The book kind of goes over this rather quickly, but I'll just say up until or everything that we've learned up until now, aldehydes would be the highest priority. So if you see a hydroxyl or an alkene in a molecule, those will be lower priority functional groups than an aldehyde. Having said that, I don't think I'll ask nomenclature of a bifunctional compound on a quiz, or I guess this would be a trifunctional compound. Anyhow, let's see here. So for ketones, you replace E at the end with -one. So if you had propane, you have propanone. If you have butane, butanone, pentanone, hexanone, heptanone, octanone, nonanone, so on and so forth. For butanone and for propanone, you don't have to include a locant for the ketone in those. So you can see that butanone, it wouldn't matter if it was on carbon 2 or the carbon next to it, it would still be carbon number 2. So there's only one possibility for butanone. Same thing with propanone, which is acetone. You don't have to say 2-propanone because it's the only carbon it can be on. It's not until you get to pentanone, so 1, 2, 3, 4, 5, that you get isomers, right? I could have 2-pentanone or I could have 3-pentanone. So there you go. Anyhow, so obviously the number of possible isomers is going to increase as the carbon chain gets longer like that. So the parent chain, when you're naming a ketone, has to contain the carbonyl group. The carbonyl group, same as always, we give it the lowest possible number. And it can be expressed before the parent or before the suffix. So you can see for this molecule here, I think it's pretty obvious that the carbonyl should be given number 3 instead of number 5. That would be the reverse order. So you can name it 3-heptanone or heptan-3-one. Either one is perfectly acceptable. So if you put either one of those on a quiz in my class, I would deem that the correct way of doing it. Either way is fine. What else? The configuration of a chiral center is always indicated at the beginning of the name. That's the same as alcohol nomenclature or alkane nomenclature. One little interesting nuance here is if you have an aldehyde next to a ring or on a ring, it's called a carbaldehyde. It's kind of an interesting word, the carbaldehyde. So if I have a cyclohexane with an aldehyde attached to it directly, it would just simply be cyclohexane carbaldehyde. You know, if you had a cyclobutane, it would be cyclobutane carbaldehyde, so on and so forth. So carbaldehyde. So that's something you'll definitely want to have in your quiver of arrows for nomenclature. Anyhow, this is kind of a fun part here. It says IUPAC also recognizes the common names as parent names. So going off what I said about aldehydes, so if I had an aldehyde with 1 carbon, well, if I have a 1-carbon alkane, it's methane. So the IUPAC name, okay, the systematic name would be, for this compound, would be methanal, okay, but we give it a common name, which is formaldehyde. Same thing with the next compound. It says acetaldehyde. The systematic name would be ethanal. So ethanol, and we call that acetaldehyde. And if you're thinking there's no relationship, between ethanol and acetaldehyde, well, there isn't really. But once you get to propanal, it gets a little bit simpler. So, and then this next one here, we simply call that benzaldehyde. So I took this table from a different textbook because I thought it was so useful. So here you have methanal, which is called formaldehyde. When you have 2 carbons, that's acetaldehyde. When you have 3 carbons, propanal becomes, and let me underline this, propionaldehyde. Butanal becomes butyraldehyde, and pentanal becomes valoraldehyde. Valoraldehyde's easier to remember because my students told me, I have a V at the beginning, so it's like a Roman numeral 5, and it has 5 carbons. Another thing about the nomenclature when you use the common names only, right? Let's say I had pentanal, so I'll draw pentanal here. So 1, 2, 3, 4, 5, like that. I would number it, giving the carbonyl the lowest possible number. So 1, 2, 3, 4, 5. That's the IUPAC way of naming. Numbering, excuse me. That's the systematic way. If you use a common name, so if you use valoraldehyde, so or butyraldehyde or propionaldehyde, whatever, the carbons aren't numbered. You don't give them a number like 1, 2, 3, 4. Those are the numbers, right? You give them a Greek letter, so alpha, beta, gamma, delta, so on and so forth. Now you might be asking yourself, are there any common names past valoraldehyde? Of course. But you don't have to know them for this class. I would suggest knowing these because they come up so much, or these common names will come up so much in the carboxylic acid chapter. So if you've ever heard of formic acid, acetic acid, propionic acid, butyric acid, and valeric acid, well, that's where they come from. Anyhow, let's move on. So let's try a problem. So let's try and assign an IUPAC name to each of the following compounds. All right, this shouldn't be too bad. So first compound, okay, it's an aldehyde, so I'm going to assign carbon 1, 2, 3, 4, 5, 6. So it's a hexanal. So it's a hexanal. What substituents on it? I have a 2,2-dimethyl and a 5,5-dibromo. Bromo should come first, so this should be 5,5-dibromo. and then 2,2-dimethyl. What did I say it was? Hexanal. There we go. All right, the next one's even more fun because it's got stereochemistry in it. We find the longest carbon chain with the carbonyl. This is a ketone, so it should go 1, 2, 3, 4, 5, 6. So this would be a 2-hexanone. I'll work backwards here. So 2-hexanone. Okay, what substituents does it have? It has 1, 2, 3 methyl. So it's got a 3, 4, 5 trimethyl. So I'll put that into 3, 4, 5 trimethyl, like that. And then I have to assign stereochemistry at carbons 3 and carbon 4. So let's see here, 3 and 4, like that. So at carbon number 3, I go from the carbonyl over to this big group over here. So that's going to be going counterclockwise. I reverse it because the proton is out in front, so that becomes R. And then carbon number 4, I go, so that I have carbon, carbon, hydrogen, carbon, carbon, hydrogen, but this one has the carbonyl. So I go from this group to this group, but then I reverse it. So this one would be S. And again, I reverse it because the proton is out in front in this case. Anyhow, everybody probably knows that. So that's 3R, 4S, 3,4,5 trimethyl 2-hexanone. The next one is the 5-membered ring would be cyclopentane. So this becomes a cyclopentanone. I have 4 methyl groups, so I have 1, 2, 3, 4, 5. So I have 2, 2, 5, 5 tetramethyl cyclopentanone. There. All right. So the only thing that you could change in these would be here for the 2-hexanone. If you had put 3, 4, 5 trimethyl hexane 2-one, that would be perfectly acceptable as well. All right. So that's the end of part 1.